It's astonishingly quiet in here, so I think I'll just sail into that opening and start, although I suspect we may have a few stragglers. I am, as some of you know, Tom Bruce. I work at Cornell on a small website there. Sara Frug is our Associate Director for Technology. We're splitting up this presentation. I'm doing all the stuff that doesn't involve any substance. Sarah's doing the rest. The title originally was Topic Models, What's in Your Sock Drawer. On advice of my lawyer, I determined that this was too intimate an approach for Cali. So we'll say very little about the sock drawer except by implication. What we are going to talk about today is a thing called unsupervised topic modeling, where unsupervised means very little human intervention in guiding what a piece of software does. We're going to talk about what it's good for, we're going to talk about what we've used it for, and what others have used it for, and what you or others or we might do with it that we haven't done yet. I actually happen to think that this is kind of a big deal. In fact, a big deal at the scale of potentially having the same impact on legal scholarship that empiricals have had over the last 6 to 8 years. And you know, I'm very excited about it. I'm something of an evangelist. I hope to make its case, at least partially, through some of what you're going to see today. It's a tool, fundamentally, for discovering topics within large collections of documents, what a large collection of documents is about. So think lots of cases on the order of tens of thousands, things that previously nobody has wanted to spend much time with because it just looked like it was too hard to separate the wheat from the chaff. Congressional committee prints, I think, are a pretty good example of that. Gray literature, things like digitized collections of personal papers, all of those Nuremberg transcripts that you guys at Harvard are piling up. You know, what are those about? And this is a tool for surveying that quickly. It rose to prominence in the digital humanities world among historians, notably, who have used it for all kinds of stuff. But you know, there's been a guy who's done research on entire newspaper archives from various times and places. There have been people who've used it to go through large collections of personal correspondence. All of that mysterious stuff that's in some digital archive somewhere where nobody really quite knows what it is because there's 10,000 files of whatever in it. And it's part of a set of law and computation technologies that I think increasingly everyone's going to be want to become familiar with. People have asked me about 4 times at this conference already what this has to do with e-discovery. And the answer is it relies on, well, one answer is that I'm really bored with e-discovery. I would have thought they had discovered all the E by now. But the other way to approach it is to say, look, it's basically the same kinds of technologies as machine learning applied to discovering the aboutness of a particular set of documents. The particular techniques used, I think, differ somewhat, but I'm not an e-discovery guy, so I don't really know for sure. Here's a way to put it much more simply. It does your skimming for you. It sorts hay into haystacks, but it will not find the needle in any given haystack. This is not a precise search tool. It's a way of doing categorization without much human intervention in the process. So let's talk about the basics of what it is. Assume that you've got a collection of documents that represent some kind of discourse, which is just a fancy way of saying they're all about something or some things. Assume that that discourse is made up of a bunch of topics, right? So here's a bunch of documents that are some guys talking about people who have gone bankrupt, right? It's a set of bankruptcy cases or whatever it might be. For our purposes today, a topic is simply a cluster of commonly associated keywords. In other words, it's a bunch of statistical software saying, here are a bunch of words that are frequently found together in particular documents, and I, the machine learning algorithm, believe that this means that those documents are all actually about something, or more accurately, I can tell you statistically what the probability is that they are about the thing that this cluster of keywords represents. As a matter of practical use of the software, you then guess the number of topics you think that are in there, and the software uses fancy math to find the clusters. There's a set of very simple, familiar activities that you can imagine kind of simulating what the software does. So suppose that you're crazy enough to be reading an article on genetics, and that you have with you a pile of colored highlighters. And you decide, okay, as I read this article, I'm going to go through and make all of the words that are associated with particular topics that I think are in this article, I'm going to color them a different color. And when you're done, you count them all and you make up a set of histograms that tell you what you think, what words are associated with what topic and so forth and so on. This is essentially what the software does. But what the software does is essentially make statistical guesses about what topic each word might belong to, and it does that repetitively until it has those topics refined into keyword clusters that you can use. There's a ridiculous amount of math behind this. If you want to look in Wikipedia, there's a reference at the end of the slides to an article on latent Dirichlet allocation, which will show you more Greek symbols than you ever thought were possible, and basically tell you what I just told you. Again, what it's good for is finding out what's in a big collection of documents. But once you've done that, there's lots of stuff you can do. So for example, we've been working with one guy who has this idea that people talked about crimes and criminality very differently in the 1980s from the way that they do now. So if you imagine we're in the Willie Horton era, and we're looking at all of those congressional floor debates and op-eds associated with the notion of, well, who's a criminal, what's crime about, et cetera, et cetera, et cetera. Now imagine, so we have that corpus. Imagine that we now fast forward to the year 2000, 2002, where people are starting to break down the Rockefeller drug laws. They're talking about prison reform. They're generally looking at a problem of over-incarceration in the United States. And we're looking at those same kinds of data sources. We're looking at congressional floor debates, op-eds, what have you. Topic model for the 1980 set, topic model for the 2000 set, compare and contrast. Are they talking about the same thing? So one use of this is to look at particular document collections in time slices and say, how did these differ from each other? Similarly, we've used it to look at state statutes. Let me see if I can actually find one here. That comparison. So when we run this against state statutes, these are the kind of topics we detect. And I'm showing this to you for another reason, which is that actually what we get from the software is the stuff that you see in the D column here, right? It's all of these are the actual keyword clusters that the thing surfaces. Someone then has to go through and say, oh, well, project construction improvement project cost financing, including acquisition, finance, connection, et cetera, in the context of a state statute means commercial construction. Somebody has to do that interpretation. The good news is that a somewhat talented, bored, third-year tax geek can crank this stuff out at very high speed, right? We had a very talented, we refer to him as Jonathan LaPlante, HRA, stands for Hapless Research Assistant, who could actually generate, tune, and label one of these models in about 10 hours, which is a sort of typical work week for a bored third-year student working out on a research assistant basis. So it's very much something that anyone can reach. Now where was I? There. It's been used for a lot of really weird stuff. Remember that document in the context I'm talking about is document in the way the computer people talk about documents, which is to say some coherent chunk of data. There was a guy who got a hold of digitized versions of a bunch of 19th century ship's logs, pulled out all the position information that was in there, all the latitude and longitude plots, said, okay, a document consists of an individual plot, did the topic modeling across a huge number of these, and managed to derive a fairly good map of 19th century trade routes across the Pacific, because he could see where these were all, where the latitude and longitude information was clustered. People have put it to all kinds of ingenious uses like that, starting to do it in bioinformatics and all sorts of other areas. But we'll stick to the law for today, but it's a very, very versatile technique, and it can be combined with other kinds of empirical stuff. One of the things I want to use it for is to try to find narrative patterns in IRS written determinations, which I think probably have little memes that float through them that we're unaware of that might actually be helpful in helping people to search for. The software that we use is called Mallet. It creates 3 or 4 files, and you actually just saw an example of this, and I went through the labeling thing, so I won't repeat it. But basically, your easiest way to understand the model is to look at that keyword file and attempt to label it, because that'll give you a pretty good idea of what's in there. But I am now going to step out of the way and let Sara talk about how you actually make these things.
All right. First step, choose a corpus. Sounds very simple. The process, Tom mentioned our hapless research assistant who very painstakingly went through and developed these models. Is a little bit more painstaking than just the labeling part. It requires a number of iterations to tune all of the different kinds of parameters that you're going to need and all of the different components that you're going to need. And so the choice of the corpus can be in 2 stages. One is the entire corpus of documents that you want to work with in the end, and the other is the fairly representative test corpus that you want to do in order to get some quick iteration over all of the things that you need to address in order to get a high quality topic model. So typically you select a sample from a big corpus. The documents want to be no more than 1,000 words or so long, and for legal text that can be a little bit tricky. You need to make some decisions about that. Pick a number of topics. We have usually started with 100, depending on whether the corpus is that variegated. You could start with something closer to 50. We run the software, and then there is a very extensive iterative process of tuning the stock wording and other kinds of features of the text, which I'll get into, and then increasing the number of topics and going through a set of iterations until you're prepared to label the model. The reason labeling happens at the end, if it's not obvious, is that it can be fairly time-consuming, and it's not something that you want to bother getting 100% right until your model is fairly stable. So for pre-processing the documents in the corpus, there are a number of things that you can do in order to get the corpus into shape so that the ultimate model will be a little bit better. There is a phase of terminology extraction where you can select phrases that you want this topic modeling software to be aware of and provide them to the software, and then the software, when it's building its model, will be able to take the phrase as a single token rather than breaking it up into its constituent words, which might or might not be beneficial to the ultimate model. We, as an aside, had a couple of examples where the recommendation was to present the phrase to the software and then present the individual tokens to the software as well, because we were losing some resolution when we did phrase extraction. So there's some tinkering to it. We do stemming and limmatization of the terms. That's another thing where it's much easier to make decisions about that once you've run the software a single time and looked at the kind of tokens that are coming up. And you'll see in a minute what that looks like in our workflow process. Normalization of terms, which is just taking the variety of words or phrases that are associated with a single concept and reducing them to the concept in cases where you don't care about having that kind of resolution. A favorite example of mine is that there are areas of the Code of Federal Regulations that contain a large number of geographical coordinates. And when we were working on the CFR model with engineering students and with Jonathan, we decided that for our purposes, it was enough to say coordinate for each one of those, and they just collapsed all of those different numbers into a single term. And then stop wording, and very labor intensive and tricky, and something where it's a process that requires a certain amount of squinting and a certain amount of squinting over the results once you've done that. So more information on stop wording. The purposes of this can include filtering discourses. Sometimes there are discourses in a corpus that you're not very interested in. Sometimes you're not very interested in procedural information in the corpus, or sometimes you're only interested in procedural information. There are sometimes a lot of geographical terms that you might not be so interested in, or for some purposes you might decide to replace them later. There are a lot of common terms that may not be immediately apparent, especially in a general purpose stop wording list, but that once you start to look at what the model is coming up with, you realize don't provide any additional information. So if you're doing a model that is just for the Code of Federal Regulations, you are likely to want to suppress terms that are associated with just the Code of Federal Regulations, like CFR or other things like that. And then we have this item under the algorithm just derails every now and then. Sometimes there are just terms that appear in the corpus that it's difficult to come up with a cogent explanation for why they're there or why they're wrong, but they are not illuminating. And the tricky part, how do you know when you're done? So we tend to say that this is more an art than it is a science. There's a lot of science behind it, but ultimately you can come to topic modeling with a number of purposes in mind, and many of them can have to do with what sort of information is suitable for your audience in interacting with this corpus that will enable them to discover information or traverse information more readily. And so because of the statistical nature of the software, it is an application that will not necessarily come up with the same results every time. It's not intended that the model be a scientific representation that is a machine-generated ontology along the lines of what you would do if you were categorizing the material yourself. It's intended to be very bottom-up and to give you information about how the documents relate to each other and what are the alternative arrangements of the materials and those kinds of things. We have found that tuning and labeling can be done by a research assistant after a fairly minimal amount of training. And one of the things that we did this semester was to work with our research assistant, the law student, and Masters of Engineering students to develop an extension to an existing one-off visualization that had been done by Andrew Goldstone that is intended to show the different facets of a topic model that are generated out of the software users. I'm going to show you a couple of things about that in a minute. We should say that this is very young software. There's a lot of active experimentation going on right now. At the moment, there's a graduate student in computer science that we've been working with who has devoted at least the better part of the semester just to the question of the effect of stemming on topic models. And it's a little bit counterintuitive, but the way that David Mimno, who is the maintainer of one of the major topic modeling software packages, has put it is to understand that it's an active question. How much effect does the corpus have on the model, and how much effect do all of the different inputs that you can provide to the software have on the topic model? So we're looking at providing some support for people who are involved in the process of building topic models and tuning topic models. The purpose of that is data exploration, including stop word tuning, making these kinds of stemming and phrasing decisions, deciding what size of a model to make, how many topics, should it be 50, should it be 700, and getting a sense of how the model changes over time. So is there in the corpus of documents, is there a discourse that's present at the beginning that has disappeared by the end, or the other way around? These are screenshots from the visualizers. I detest live demos. I want to show a couple of features and give you a sense of the way in which this presentation can be helpful to model developers. We have a topic list view which helps visualize what are the prominent topics in the corpus. How do the topics change over time? You'll notice that in this view there are a couple of topics that are not very prominent at the beginning and are more prominent at the end. There's one that spikes up in the middle and then becomes less prominent. And there can be a wide variety. The topic model that you're looking at is a fairly stable model, and you'll see a slide that shows that more apparently in a couple of minutes. But this is a model of Title IX of the Code of Federal Regulations in time slices over time. You'll notice there are a couple of missing pieces. Those are years that we don't have data for. But this is a topic model that's intended and expected to be fairly stable over time because there's not a huge amount of activity, but to have some variations because there is active regulation.
So Sarah?
Yeah.
Those were chronological graphs, those little snippets of graph?
Yeah, the little barcode-y things on the left are essentially histograms in one-year time slices.
So the label on that is 2000 to 2013 were the time slices. The missing bars are just years when we don't have data available, and the lines show how prominent in the corpus particular topics are. From the topic view, we can get to any individual topic, and it shows the prominence of the topic in the corpus over time, the most important documents that are associated with the topic, and the terms that are also associated with the topic. This can be somewhat helpful in getting a little bit of a better sense, and from this view, model developers tend to drill down on a particular document to see what is associated with that document. Also can drill down on the top words in the document. I'm going to go to the document view, and in this case, this is Part 93 of Title IX of the Code of Federal Regulations. It contains a lot of agricultural regulations associated with plants and animals and inspections and import and export. And this particular view is showing a ranked list of topics that are associated with the whole of the part in Title IX. We can make the granularity. We built the model this time based on part granularity. We can also build it based on section granularity.
One quick thing to jump in with, if you look at those blue bars on the side there, the best way to describe what that's doing is that it's talking about essentially the relative percentage to which this particular topic, which this particular document participates in that set of topics going down the side there. So you can think of it as a kind of participation score, if you like. That actually turns out to be quite important to something we're going to show you later. More so because it's highly corpus specific in how it falls out as you move through the documents. This one is actually a fairly smooth curve, as you can see. When we get to case law, you see a much more of a shelving phenomenon where there are a couple of documents that rank very highly, a couple that rank in about the middle, and everything else is at the bottom. And one of the things that we're desperate to know is to figure out where reasonable cutoffs for relevance are along that spectrum. It's actually quite hard to determine. It's an active research question. I get very puzzled looks from Minnow every time I bring it up. Or actually, I should say, looks at silent movie hatred me. it's a tough problem. But it's worth knowing about. Sorry to break the floor.
No, we could also add that there are some corpora that we've worked with already that present results that are a little bit unusual from the perspective of the researchers who work in topic modeling and have worked with corpora from other domains. And so there are some potentially interesting research questions in terms of applying the same kinds of configurations to legal text versus other kinds of text, and seeing where those fall out, and whether that effect was distinct to the particular corpus that we were working with, or to legal text in general. A couple of other things that we find useful, I was talking earlier about stemming and lemmatization and normalization. We have a word list view that enables us to fairly quickly take a look, and we usually just do this by scanning and see whether we were really interested in going through some kind of stemming or lemmatization process. In this case, we can find some singular plural stemming that we might be interested in doing. We've been admonished not to be too aggressive about stemming because the preliminary results of the research indicate that it's more reliable to be a little bit more conservative about that. We also, and this is something that one of our students, Josh Campbell, added to the existing visualizer, which was a tool for stop word evaluation. What you see on the screen is a set of words associated with each topic in which the proposed stop words are presented in red. If you squint closely at the stop words that are being proposed, you'll probably guess that those are based on statistical prominence in the corpus, and at the moment that list is being populated just on the basis of most common terms. It could be populated in other ways, including by using machine learning techniques based on the feedback that the model developer provides, or using other kinds of algorithms that would take a different approach to proposing those kinds of stop words. This is a big set of dots. What we find it to be of some utility for is
we licensed this from Rabble.
We have found this useful to give a fairly quick overview of how much the topics that we've retrieved overlap, and to what extent we have distinct topics in the corpus, and where we do have topics overlapping, it's possible to drill down pretty closely and see how conceptually close they need to be together based on the terms that they include. And then we have this pretty picture, and it's probably every time I've shown it to Masters of Engineering students, I think it's been universally agreed upon that this is a lousy visualization, but it can be very, very helpful just for quickly gauging whether the corpus has a lot of stability over time, or whether there are pretty big variations in the contents of the corpus as from the beginning to the end, or in the middle as time goes on. And this, again, I mentioned at the beginning, is a very stable corpus, and so this view actually can be a little bit helpful in just gauging that.
Besides, we had to pay the Tibetan sand artist a bunch to do that.
And I'm going to hand this back over to Tom to talk about the things that we've done with it.
Okay, so we played around with it. I mean, we've said all this stuff already. We've done a lot of stuff with case law. I'll say a bunch more about that in a minute. A little bit with legal scholarship. We ran a whole lot of SSRN abstracts through it. It's kind of useful in that way because, and if you're thinking about case law categorization, you're thinking, well, why wouldn't you just do that on the basis of citation networks? Or some other kind of Bayesian thing, like a spam filter type application or something of that sort. But it turns out that those perform very differently depending on what area of law you're talking about, right? So if you've got an area of law that is essentially a child of statute, so copyright or social security or what have you, it's going to perform very well because citation detection will pretty much capture all of that. You know if it's Title 17 is copyright, what have you. But when you start going off into areas like constitutional law, or I suspect some of the international stuff, John, that you work with, it's not so clear, right? That something is a free exercise case or isn't, or that it may in fact present multiple issues without statutory citation and that kind of thing. So in that respect, this kind of outperforms that. I'm going to show you a little bit of that in a minute. Discourse comparison, we talked about that. We did that with state statutes. It was kind of interesting that it needs to be taken a lot further than we've taken it. It's no big thing to run a topic model on the Delaware state statutes and realize that they're kind of concerned with corporations there. And you know, there was a conversation in which Jonathan walked into my office and said, "I need a state that doesn't have a shoreline," because things look very different, right? But it is a kind of good rule of thumb for seeing where certain things are better developed than they are in others. The other thing that's kind of nice about it, by the way, again, back to categorization. We've got a model for bankruptcy that was done by running about 15,000 federal bankruptcy cases. And we think, based on what we're seeing of how well it categorizes, that it ought to be possible to do very fine-grained current awareness services based on this, because fortunately for us, it tends to err on the side of false positives. And the nice thing about a current awareness service is that nobody cares if your false positives are there, so long as they stay under about 10 or 15%. So it fits that nicely. It would be a very nice basis for legal news feeds around very fine-grained topics that otherwise would just economically not be possible to compile and deploy. And CFR temporal snapshots, as Sarah was showing you, another example, sort of discourse comparison across time. I'm going to show you something in a minute that is unimpressive in its screen presence, but actually sort of impressive in what it does. Turns out that if you have one of these models that has been trained on some batch of cases, you can throw something from outside the training set at it and say, okay, where does that fit in the topical scheme that you've managed to construct? In other words, you can use a finished model as a categorizer using statistical inferencing techniques that are actually built into the software that we use. We have such a model. We trained it on 25,000 cases pulled randomly from Court Listener from across all jurisdictions, time spans, et cetera, et cetera, et cetera. It's about, I think, 1% of the cases that they have. It ended up turning out to be 19,000 cases because we discovered very quickly that anything under 3,000 bytes was not particularly useful, not because it didn't say much and not because there wouldn't be valuable information in a case whose text was smaller than that, but because they were overwhelmingly, because I said so, memorandum opinions that really didn't have much substantive content whatsoever. They were essentially administrative or corrections or something of that sort. 3K was a reasonable rule of thumb cutoff. We didn't really care how big the training set was, so it was just easier to throw them all. 500 topics, that was a number that we arrived at by the iterative process that Sarah was describing earlier, which is to say we basically kept increasing the number of topics until we had the kind of granularity we wanted in what it was finding without it generating a huge number of junk topics. We tried to keep that under about 10%. I still have the feeling about these junk topics, some of them, that Lassie is trying to tell us something, but I can't yet find the particular well in which Timmy is located. So that's kind of an open issue. How many of the topics are really junk, and how many of them are just commonly occurring words around things like civil procedure that might actually have some meaning. We haven't quite figured out. We did a little test implementation that's done in JRuby, a slightly hacked version of Mallet, the modeling software, Tika and Tesseract for input doc conversion. And I got a couple of examples to show you, one of which involves a kickboxing instructor. That one's here. So this is a woman in the 2nd Appellate District of California who sued a sports club. Oh, here it is, right up on the screen. She got a knee injury while she was in a kickboxing class. An instructor was helping her. She'd signed a waiver of liability, but the plaintiff was arguing that the instructor's conduct increased the risk inherent in kickboxing and constituted gross negligence, meaning he just told her to do the wrong thing and she got hurt. Let's look at what happens when we run that against the model. Here. We're going to pick out the actual file that has to do with that case. This, by the way, is a as a Word doc, and the softwares we have will convert pretty much anything on the fly. It's a little slow when it does that. So if we run that, what do we get? Well, the top four are torts, premises liability, torts, proximate cause, civ pro, summary judgment, and student employment, oddly enough, because it seems to be picking up on the student keyword. It's really quite impressive, given that it was not actually trained on that. Similarly, I don't know how many of you are familiar with this, but Pablo, I think, was intimately familiar with this. There's a book about it, I am now told. This was a case in which all of the world's whales sued George Bush and Donald Rumsfeld over the U.S. Navy's use of certain kinds of sonar. Now, this is not something that, so far as I know, you can find in the West key number system. Although I welcome corrections from any librarian sufficiently familiar with the West system to tell me. You know, Craig spotted very quickly. Where is this miraculous first? Oh yeah, that this was he first detected that this was not going to go well at the point where he saw the judge's language, the name chosen by the whale's self-appointed attorney, which we took as meaning this guy is in for a world of hurt, which was indeed what happened. So if we run that, we pick up the whales, and we do magic with it. We see, yeah, we're looking at wildlife conservation, legislative intent, something to do with agency and administration on the part of the agency, and merits to sue. So, really pretty good, and that's just the top four. We slice those off because of that shelving thing I was talking about earlier. It turns out that for case law, if you take the top four, you get pretty good results. The last one I'm going to show you is row. Because I think that every time I show this to people who have actually been to law school, that group not including me, there's this moment of doubt followed by sudden comprehension when they look at the results. What do we see? Well, clearly we see abortions, and clearly we see equal protection. But there's also med mal and legislative intent. And some people have told me that there is actually a substantial component of row that is about medical malpractice. Is that right?
So, the guy who wrote the opinion, his name,
Blackman.
no, I'm sorry?
Justice Blackman?
Yeah, Justice Blackman. There's Linda Greenhouse wrote a book about him, and she went into all the archives. So before he became a justice, he was chief counsel at the Mayo Clinic, and his whole opinion was structured around, this is autonomy for doctors, that doctors should be able to decide how to treat women.
Yeah, that's exactly right.
And so yeah, that makes perfect sense.
Right, so a very non-obvious thing that this is sort of managed to pull out of the language of the opinion. And that's all I got for the magic show. I mean, we could do stuff to jump to it, but I'm not sure it would help us much. So future work, I mean, obviously the effort is all in stopward list construction. One of the things we found when we started working on case categorization, it was a sort of poster child for stop wording problems, because we ran this thing, and somewhat to my surprise, we very quickly discovered that there are actually two discourses going on in case law. One is about substance, the other is about jurisdiction. So we essentially had to stop word out all of the court names, geographical entities, et cetera, or we were getting these topics that were about the thing being from the Fifth Appellate Court in Mississippi. And that sort of stuff. So it was a perfect example of kind of, oh yeah, there really are two things, very much to our surprise. I don't know, Sara can tell you what's being done with automated stop word list construction. She's looked at the literature, and I have not, but certainly named entity recognition would help. Automated labeling is another big topic. I mean, we have Jonathan, the hapless research assistant, and presumably he will have a successor as a hapless research assistant who can help with this stuff, but it's time consuming. Nobody really knows, and it's probably highly corpus specific. You might ask, okay, so you've got this 500 topic model for case law. Suppose you ran a 250 topic model, a 100 topic model, and a 25 topic model. Would that represent any kind of topical hierarchy? If you looked at the topics you've got, could you conceivably map those into anything that was a kind of conventional ontology tree structure. We don't know. The guys who do research in this don't know. Everybody wants to find out. And finally, as Sara was saying, there's need for better visualizers, both to support model development and support model presentation, because there's a lot of stuff about this that's counterintuitive. And really, the visualization tools that are out there tend to be stuff that was written as one-offs for some particular project, where the guy said, well, I can add 5 lines of code and make it generally useful. That may or may not have been a correct call on his part. So there's lots of work to be done on practical tools for these things. And with that, we will stop. If you look at the slides as they were uploaded onto the site, I'll just run through these very quickly. There's an extensive set of links to outside stuff that explains this far more clearly than we did, and a guide to tools and that sort of stuff. So that's that. Who's got questions? Yeah.
So to your last 2 points about visualization and about hierarchical modeling, are you familiar at all with the tool called Overview? That's, I think, now owned by the Associated Press?
Yes, I've seen it. I don't know it well.
So they're open source, and I would encourage you to take a look at it and try to incorporate some of their code, or some of their practices into your work, because they have a number of different visualizations. And they actually emphasize hierarchical categorization and tagging, where you can sort of isolate little clusters within clusters. And the visualizations are all driven around that. So just something I wanted to point out and encourage you.
You can feed this thing any old source data you got?
Their emphasis is on news articles, but I believe other people have done it with more specialized content than that. Okay. I think someone was doing it with like medical journal articles and was getting pretty good results out of it.
Okay. It's good to know. Yeah, Paul.
So I'm curious about when you have phrases that are highly suggestive of the topic, but are made out of individual words that are not on their own, how that plays in. So I did patent litigation, and there's a phrase, person having ordinary skill in the art. 99% of the time that's going to be a patent case, but of course the word person and the word having and ordinary and skill alone are not suggestive.
Yeah, Sara spoke to that point earlier. That's the terminology extraction stuff.
Yes, so one of the steps, I think we collapse it sometimes under stop wording, but it's possible to extract terminology by which we mean, maybe I should take a step back actually. The topic modeling software off the shelf will treat each word as a token, and it will do a statistical analysis, and it will cluster the tokens that appear together frequently as topics. What the terminology extraction phase of the development process does is it enables you to take any phrase that is prominent or important to the corpus, whether you get those phrases out of a legal dictionary or out of, for instance, we've used lists of federal agencies and programs or lists of named legislation, those kinds of things, and to feed those to the software and tell the software, this is a phrase, you should treat it as a phrase. Or alternatively, feed it to the software and say, treat this as a phrase, and then also analyze each individual word in this phrase. And that's another thing that you have to go through and tune. We had a number of places where we would, if we treated, for instance, names of legislation only as phrases, then we would lose topics that we needed, and so we needed to take out the individual terms. You can think of the Federal Food, Drug, and Cosmetic Act, and losing all of those individual tokens. So there's a little bit of complexity to it, but the point is that you can interact with the software and give it more to go on via whatever means you have available. One approach that's been used is that David Nimno, who's a malmaintainer and a computer scientist at Cornell, he describes a technique of just mining Wikipedia for anchor text and feeding all of those to the software as phrases. So there's really quite a wide range of sources for that.
But to date, you haven't used phrases that are like 9 or 12 word actual legal documents.
No, and that would not have any effect on performance. It would obviously add to the work in preprocessing. Frug. There's terminology extraction software that's really pretty good at finding the full extent of the thing, right? So if what you're ultimately after is the 5-word engram, for however many words there are in federal food, drug, and cosmetic, you don't want it to stop short, right? And there's actually software that's quite good at that. The example I've been throwing out, because it's such a silly example, because it presumes a crazy librarian. And there are none of those. So imagine that you start out with this collection of decisions that are basically about lending in some way. So you got a topic that shows up around collateral. And then because you have a crazy librarian, they decide to add to that a collection of documents about war crimes. And suddenly you're individually considering collateral and damage. Right? And now as our final step, a civil procedure librarian comes along and throws another bucket in there that's full of stuff about collateral estoppel. Right? So you can see why this is needed. I mean, you do see why this is needed. But all I'm saying is that it's possible to get some very wildly misguided stuff if you don't do that. And so it's well worth the work.
And the same goes for disambiguation or rhetoric stemming.
That was going to be your question.
Things where you have a term that it just has multiple word senses. A preprocessor, you would make use of a preprocessor to go in and identify the word senses, and the topic modeling software would then consider each of the word senses as a different tone.
So you do that against WordNet? Is that how people are doing it?
WordNet is a common way of doing that. Sometimes in conjunction with other tools.
More questions? I can hear you breathing.
What would you like from us, Tom?
More models, more data. I mean, look, there's a range of stuff over which this can be usefully extended. Let me give you a couple of examples of things that I think would be good short-term applications that I would at least want to try. Right? None of this is surefire, but. So we have that thing I was showing you guys in the show and tell over lunch where we've linked all of the IRS written determinations to the relevant sections. Now this seems like it would be a really good research tool, and it is. But it's got a little bit of a fire hose problem because, of course, those written determinations are not evenly distributed across the entire tax code by any means. So if you look at Section 501, there's something like 17,000 written determination letters. All of them with titling that is vaguely duplicative because that's what the government tends to do. But within which I am sure there are any number of subtopics for which there is no real treatise anywhere and no real ontology anywhere. And in my mind, it's kind of a toss-up how you would help the user most. Do you offer them some sort of sub-search over those 17,000 documents that will take them to some pinpoint of exactly what they want? Or do you do a topic model that's much better at showing them the gist of everything that is in there in the hope that that gives them a better framework from which to actually do their research? I mean, one answer, of course, is you do both. But what I'm saying is that there are, I believe, that there are sort of user information seeking scenarios in which having a set of topics, even if that you can drill into, is far more useful than being able to do full text search. So that's one set of stuff, generally speaking. There are also places where other sorts of techniques fall short. I was talking to Steve this morning and crying about some Immigration and Naturalization Service documents we've been looking at that are similar to these IRS written determinations in that they're responses to individual appeals that say, approved, denied, whatever. Their favorite redaction tool is a black magic marker, which plays hell with OCR conversion in PDFs, even in the stuff that's not redacted. I mean, we don't care about the stuff that's redacted because of the image contrast, it screws them up. This is particularly bad because most of the citation that takes place in these letters takes place at the subsection level of either Title 8 CFR or Title 8 USC. They happen to be numbered identically in the case of immigration. And so they are long strings of numbers and parentheses that are particularly vulnerable to mistreatment by OCR standards. And you think, okay, well, how well can I do? Well, with the best correction software that I could write in less than a century, we can only get up to about 70% on the citations. So my question at this point is, if we take the citations that we can find cleanly and topic model that, much like our friend with latitude and longitude, do we find stuff that provides a reasonable basis for association with a particular section of the code? That's the question. I mean, so there what you might do is extract all the terminology, as Sara was suggesting a minute ago, out of the code, look for those significant phrases across the letters, and do your topic modeling just on the basis of those significant phrases that occur in the statute. There are many ways. What I want you guys to do is play with it, because I think there are a lot more uses than we found. And I also think, I mean, we haven't talked at all about the uses in faculty scholarship today, but really just the potential for comparing discourse across multiple formats. That's going to be a big deal for these guys. A very big deal.
I recall Dan Dabney, well, many years ago at this point, talking about why West does not and will never, I believe he said will never, try to use algorithms to maintain the key number system when ingesting new material. Is this an indication that we're...
No, there's an important point to be made there, and it's a general point about this kind of work generally, whether you're doing topic modeling or not. Everything that we've done that rests on any kind of statistical or natural language processing technique, which practically speaking we have to use to operate at the kind of scale we need to make credible features out of this, has this same problem. There's a well-understood view of that material out there in the legal community that's based on some kind of formal ontology like the West key number system. Now, from an irreverent perspective, the West key number system is 8 guys sitting in Eagan, Minnesota deciding what the law is, basically. And you can go back through all those Bob Baring articles on indexing and dance around the holes and corners of that. But I mean, at the end of the day, that's what it is. It's a totally top-down approach. This is a data-driven approach. This is a bottom-up approach. This is what you get when you look at the data itself. We were actually astonished. I didn't show this. I can show you the labels, but take my word for it. We had Hapless Research Assistant do a 300-way model on 15,000 federal bankruptcy decisions with a specific eye. The question I posed to him was, well, Jonathan, when you go to do your labeling, just as a sort of interesting thought experiment, let's see if the categories that we get when we go to label this stuff actually correspond to stuff that's in Collier, right? Which is the leading bankruptcy treatise, and it did 100%. So everything that we found in there could actually be assigned plausibly to a Collier topic. Did we achieve 100% coverage of Collier? No, I don't think we did. We haven't actually looked, but there weren't that many topics. So, you know, Lassie is trying to tell us something there. So it's not bad at reproducing top-down hierarchy. The point is that in any project like this, when we've tried to do information retrieval projects based on hierarchy, based on ontology, any of that kind of stuff, when we've done data models, you'll recall a moment of this in the legislative project that we put together, right? I mean, you get to this point where you say, okay, I've got what's being suggested by the data, and I've got what's suggested by the formal ontologies in the field, and somehow I have to reconcile those in the middle. I can't just use one or the other.
But Wes could, for example, use a topic model to predict as a decision aid, right? So rather than have to read the whole thing and decide from scratch where it belongs, say, well, the algorithm says it belongs here, is the algorithm right? And hypothetically, that'd be far more efficient than...
And indeed, Dabney was being a bit disingenuous there because they do use a voting system to categorize. It is software-based.
Yeah, I was going to say, I talked to the West guy at Stanford last month, and he said about 75% of their key number designation is done by algorithm.
I'm shocked.
About David.
saw other questions up there. I'm sorry, I spaced that. Sarah, did you, any final benedictions on any of this?
No, one thing that we were curious about, though, is whether this would be a labor-saving device for institutional repositories that are bringing in very large volumes of, let's say, law review articles or other kinds of texts that haven't been categorized, and that for which the cost of doing traditional cataloging practices would be prohibitive. And so that's a little bit of an open question. I think it has any potential.
I mean, specifically, Cornell has been submitting new work and working papers into B-Press and into various institutional repositories that have their own categorization schemes. But now that they're starting to take historical material from the Cornell Law Review and other sort of institutional sources and throw it into institutional repositories where there is no fixed categorization scheme, or where it would be too labor-intensive to follow one. I mean, we think this has a certain amount of potential. I don't know. I'm seeing nods from Steph and from Amy that make me think that we might be onto something here, but I don't know. How would that play out?
Well, from the end user perspective, when you were searching a repository, you would definitely bring you articles on a certain topic. But you're right, the main problem is, because we use B-Press, is that when you batch upload a bunch of things like that, it is just too labor intensive to individually categorize each one of them. So they all just kind of dump it. And so unless you are searching for, unless you pick it up in the title or by the author, you know, their search engine isn't pulling it up.
But you know what just occurred to me when I hear you say that? You've got training data there, right? You've got stuff already in B-Press that has been categorized.
Yes.
I wonder if there's a way to use that as a basis for building a class.
Yeah, certainly. And again, it would be in the category of support, of the support tools, that it would suggest categories for documents. That whether you would do better using topic modeling software and trying to do this predictive topic labeling using that data, or whether you'd be better off just using a classifier, I think the classifier approach seems a lot simpler because there are fewer places for things to go very wrong.
And so when we say classifier, I think spam filter. Same sort of thing. Show it spam, show it non-spam. Yeah.
This is sort of, tell me whether I'm thinking about this wrong, but in my sense, I could be really shortchanging good ontologies, but it seems like this sort of completely post-coordinate index is much more nimble to changing discourse over. I mean, I know that part of what you're looking at is a long period of time and whether these topics are really stable over time. But for something like legal scholarship, they're not going to be stable over time. They're going to be shifting. Am I right that if you continue to iterate this over time, that it's going to be able to respond to that? So that, you know, in 5 years you do the ePress searching and you're going to have the topics are going to reflect the topics that have changed?
I think it's a very quick way of determining that, because it makes it very simple and straightforward to take a brand new corpus, let's say a year's worth of materials or two, and just compare the topics that you get out of that corpus to the topics from the pre-existing corpus. And so I think it's very promising for that.
I mean, the thing is, of course, stuff as you change, you can imagine, because this is totally data-driven, as you change the documents that you're actually looking at, so as you're accumulating stuff from year to year, the nature of the topics discovered actually changes somewhat. So, yes, it's nimble. We have questions about how much instability, a temporal instability in an underlying indexing scheme the user community is going to be willing to accept. You know, I had a chat with Dan Blackaby about this very issue one day, and his reaction was, well, you know, they do tend to update them on an annual basis, so you can probably get away with doing 1-year snapshots, and in that respect, it's a hell of a lot more nimble than what key number systems. I mean, Dabney once told me that his greatest achievement when he was running the key number system, and this was in like, I think 2005, he told me this, he felt that his greatest achievement there was having managed to move employment law out from under master and servant. You know, which tells you something about the stability of that scheme. So, yeah, it is a more nimble response. There's a question in my mind about when nimble becomes teeterboard. You know.
So with the system you're talking about doing all the analysis and then assigning labels. So assuming good quality labels in the first place, you're going to get a lot of stability. And if you don't get stability, you can go back and re-examine your labels and get it right the second time.
Or actually,
you'll get expansion over time too, which is also perfectly appropriate.
Steve.
Another approach to take, dealing with the nature of acceptance over time, is to take these phrases, which are the explicit actual phrases that are there, and then to take the approach where there's a high correlation of accuracy to that phrase, and explicitly to mark that up in the XML, and then enable a many-to-one. So for that one string that's marked up, if you query that, then you can see how many labels have been assigned by whom over time. So these nascent annotation frameworks is just another approach to data processing that this, I agree, is in the context of how does this enable the time saving of what we might have thought of as cataloging. But then another approach is if we're trying to make self-describing documents through the XML markup, then there's nothing ambiguous or interpretive about the markup of the string. It all goes into what labels have been assigned to that, and you can permit that to change and evolve over time if one wanted to.
Yeah, we're past our time, but I do want to make one more comment, which is some of the things that have just been said in the questions are suggesting to me that I've not really thought through the economics of this, right? I mean, there's a well-founded belief in the library community that topical indexes are expensive to construct. What if they're really cheap? You can have a model at a high level that's spanning multiple topics in law that can be quite stable because as someone was suggesting, that the overall landscape doesn't change that much. But then if you look at some fast evolving area like, I don't know, gene patents or anything to do with environmental, you can run a sub-index of that one and basically offer the user the choice. Do you want to see the chaotic one that's up to date, or do you want to see the persistent one that offers you a few more handles, because they're just not expensive to build anymore. And that to me is actually a fairly interesting question that deserves a lot of discussion. What happens what happens when extracting aboutness gets cheap? It's an interesting problem.
I mean, you could run, like you ran with very big way through the Magic 8 Ball. You could run all the major abortion cases through it and see how has the way that the justices have talked about abortion changed over time.
Oh, sure. Oh, sure. Oh, sure. Okay, with that we have to conclude, but we're happy for follow-up.